Hello.
Hi.
Nice to see you, Asia. It's always good to hear your voice.
Aw, thank you.
I'm glad you have internet. Jim, nice to see you too. We're gonna get into a little of what I said some things to you in your homework, and we're gonna get into a little bit of that today, so you'll have a better understanding of like what I was talking about. And Shanielle, good to see you too. So I'm going to just unmic for a minute here while we wait for people to arrive and do one or two more things here with this puppy, and I'll be back in a minute. Okay, everybody. Kiana, I'm happy to see you. We're actually going to be doing your practice assignment in class today, so you'll have a benefit if you are here, because you'll complete, I think, most of it in class today together as a group. And that way you'll be in good shape for doing your final assignment. So let's see who else is here. Kiana, Sheridan, I'm glad to see. And I think more people will be coming in. Glad you're here, Sheridan. So use your hands or your voices. We're going to go through quite a lot with good examples and then do your assignments as well. So I'm going to start right off by sharing the screen. Let me just see, is there, I said hi to Asia, Jam. Can I just hear voices from Shanielle, Kiana, and Sheridan since you're also here? Shanielle, how are you today? I don't know if you're able to speak or tune in for a moment. Kiana?
I'm here. Good morning.
Good morning. Thanks for being here. Sheridan?
Yeah, I'm here too.
Thanks for tuning in. I'll share the screen and we're going to go through a bunch of stuff here today. So let's share this one. And got us set up here to get started right away. So we were working this time around with z-scores. And the z-score is just like a standard. We talked about how it's sort of like a maybe the ruler, the standard for length that we use is in the ruler, or the standard for weight that we use in this country is in the pound. And it's easier if we have standards because then everyone is sort of speaking the same language. We're all talking about the same amount and it's easier to buy and sell things. So I think, I guess you're going to see a view of the ceiling because I have to write with my camera here. You can all see the screen, I think. And so what we're looking at today is just a little review of this. So remember, our standard that we use when we're talking about our standard that we're going to be using is called the z-score. And it is, and I'm going to be marking this in, I think in purple. So our z-score always has some common characteristics. One, we know that it always has a mean of 0, and it always has a standard deviation of 1. And it is what we use for defining the normal curve. And this normal curve has these properties too. It's symmetrical, and it has that bell shape. So let's just review a little bit of this. So the mean is always 0 right at the center. One standard deviation above the mean is at this first standard deviation mark. It always falls right about here on the normal distribution. 2 standard deviations falls about here. -1 would fall about here, and -2 falls about here. So anytime we have a bunch of scores, we can plug them in and know what the z-score is. And so let's start by just reviewing that basic process. So imagine that we have a set of data that we've gathered, and it has a mean of 50 and a standard deviation of 10. We know that we can put the mean right here, and that in this sample, anybody with a mean of 50, so anyone with a score of 50, a raw score of 50, let's write raw here, that just means the basic score that they had, will have a z-score of 0. So we know that because the 0 and the 50 are aligned. We know that then if they're going to be 1 standard deviation above the mean, we simply need to add 1 standard deviation, 50. So we'll add plus 10, and we get 60. And so we know that anyone with a z-score of 6, with a raw score of 60 will have a z-score of the number right above it, which is 1. And that just means that their score is 1 standard deviation above the mean. To figure out 2 standard deviations above the mean, we'll do the same thing. We'll just add 1 more standard deviation. We know in this example, all our standard deviations are 10. So we're adding 10. And we'll find out that the z-score of 2 corresponds with a raw score of 70. We can do the same in reverse. To get the scores that are below 0, we subtract 10, because in this example, every standard deviation is equal to 10. So let's subtract 10, and we'll find out that the raw score of 40 is equal to a z, let's make a little cross here so we're clear, a z-score of -1. And to get 2 standard deviations below the mean, we just subtract another standard deviations. And so we know that 40 minus 10 is 30. So we know that a raw score of 30 is equal to a z-score of -2. So in this example, there are 10 raw score units in every one standard deviation. So 10 here, 10 here, 10 here, 10 here. And because we know that the mean is 50, we can just add and subtract these 10s and have a lot of information about this example. I'd like to go through a couple more examples of this with you guys doing more of the work. So let's try another example. Maybe these are the ages in this score. Let's give them some meaning. Let's say that these are the ages of children who attend this summer camp kind of a thing. And so we know that the average age of these children was 9, and the standard deviation was 1. And let's write years in here so these data become more meaningful. All right, so in this case, we know that, oh, hang on. There we go. We know the same thing about the z-score. The z-score doesn't change. The z-scale always has a mean of 0 and a standard deviation of 1. So this is always going to be the z-score. I recommend that you just write this down because this will be so useful to you in this content. Let's attach some raw scores to this. Our raw scores in this case are these ages. And so we know the mean is 0. And so what age would be at 1 standard deviation above the mean or with a z-score of 1? So if z equals 1, what is x going to equal, the raw score or the age? In this example, every unit in here has 1 year.
Is it 10?
And that would be 10. How did you get it? How did you correctly get that answer of 10? Just sometimes it helps to have another classmate explain. Okay, well, thank you for the answer. And this is just gotten by adding one of these standard deviations. There's 1 unit in each of these. And so we have to add this 1 again to get 2 standard deviations above the mean, which would be 11. So 9 plus 1 equals 10 plus 1 equals 11. What is the raw score that would be associated with a z-score of -1? To get this answer, we just subtract the 1 standard deviation. We just subtract the 1 standard deviation. And so we would find 9 minus 1 is 8. We know that this 8 is lined up with the -1. So we know that if the z is -1, the x equals 8. And what would be the z-score, the raw score associated with a z-score of -2?
7.
And that would be 7. And we got that just by subtracting another 1 from this number. So this is a basic outline of how this works. If I was going to calculate the problem, and let's say I was given this problem, I was going to say, we have this test and the mean score on the test was 85. and the standard deviation is 5. And the question that we're asked is, what is the z-score or the standardized score for someone who had a raw score of 90? They got a 90 on the test. What is their standardized score, or how many standard deviations above the mean is this? And if you were going to draw on the diagram to solve this problem, what would you do? What would you put first? Maybe the z-scores first, so that you can keep track of what you're doing. So 0, 1, 2, -1, -2. This will always be our foothold. And what would we put directly under the 0?
85.
We'd put 85 because that's the mean. And what would go under the 1?
90.
90. We got that by adding 1 standard deviation. In this example, every one of these segments is worth 5. And 2 would be 95. Subtract 1 to get 80 for a score of 1 standard deviation below the mean, and subtract 2 to get 75. And so in this case, if we have x equals 90 and we're asked z equals question mark, we would be able to fill in that z equals 1. And so that is how we can use this really simple concept to figure out some basic z-scores or standardized scores. And again, the language we use, we have raw, which just means whatever the data is without being standardized. So you can see every one of these has different raw data, but the standardized scores are the same. We'll look at the benefits of that in a little while. Now, in your book, there's an example that I think was a mistake. And when we come to the problems, we'll solve it. But because of the mistake, not everyone gets a nice round score like this. Like, what are we going to do if we need to know the standardized score for someone who got, say, a 92 on this particular test? And so we do have a formula for calculating this. And the formula for finding a z-score, so we need to know the z-score, is just x minus m divided by standard deviation. And to put this into words, raw score minus mean, and we do that first, it's in parentheses, we divide by standard deviation, and we'll come up with the z-score. So let's see if this works. We had figured out in number 1 that someone with a score of 60 would get a z-score of 1. Let's plug it into the formula. What this would be is z equals, let me use green actually, z equals, and the x would be 60 minus mean of 50 divided by 10, which would equal 10 divided by 10, which equals 1. So we find out that the formula works. In our second example, we found out that a raw score of 7 is equal to a z-score of -2. Let's try this out. I think I'll do it over here this time. Let's put z equals 7, the raw score, minus 9, the mean, divided by 1, which equals -2 divided by 1, which equals -2. So again, we are correct. Let's continue on though and do the example that I just gave. So what if someone has a 92 on this test right here? Can we make an estimate about what their z-score is going to be approximately? And we can do that by sort of plotting in. So we know that 92 is going to be somewhere between 90 and 95. It's going to be a little closer to the 90. So let's put it right about here for our estimate. That's probably a little bit close. Probably it's more like right around here. And what score do you think z-score would correspond with that? If all of these numbers between 1 and 2 were filled in, what would a corresponding z-score be? And I do need to have you answer so I have some idea of whether any of this is making sense to you. So if anyone wants to take a stab at this.
1.4.
1.4 seems like a pretty decent guess. Let's take that as our estimate. It's always a good idea to estimate. We're going to estimate that the z is 1.4. That way, if we come up with an answer that says like the z equals 10, we know that we made a calculation error. So let's apply our formula. Our formula is the same. Z equals x minus m divided by SD, which equals 92 minus 85 divided by 5. And so let's have someone do this math, which equals 7 divided by 5. Anyone want to run the calculation? And see if we're close? Anyone have a calculator there? You should have one on your computer or your phone even. And we get 1.4. All right, exactly. So we did pretty darn well. And our last example is similar. We would just apply the formula. In this case, we have a standard deviation of 2 with a mean of 24. So we would just go z equals 21 minus 24 divided by 2. 3 divided by 2. If we estimate first, we didn't write this one in, but let me just, there we go. We know that we would have 0, 1, 2, minus 1, minus 2. This would be z. We know that our raw would be 24, 26, 28, minus 2, 22, and 20. Our 21 would fall right about here. And that corresponds with what we would get if we applied our formula. 3 equals negative 3 divided by 2. And that gives us a z-score of negative 1.5, which is exactly what we would estimate a score falling between negative 1 and negative 2 and right about in the middle. Any questions about this process so far?
None from me.
Thanks, Asia. Hard for me to know if I'm going too slow or too fast in this setting. I'm so eager to get back to face-to-face, and I will be there next week. So that'll be helpful, I think. Okay, so if we continue, there is a formula for reversing it. It's just the opposite. And so what does this formula mean? X equals Z in parentheses, SD in parentheses. What does this imply about the mathematical computation that you should do? And if you're not sure about this, the rule is anytime there is no sign given, it means multiply. So this right here, if we were doing it in Excel, there would be an asterisk. And normally if we were writing it out, we would have a time sign. And so that's implied. And they just have the parentheses around it because otherwise ZSD, you might not be able to tell what was what. So all this means is you multiply the z-score times the standard deviation and you get the raw score. So in this case, if we were going to figure out someone's raw score, like let's say your child took a test. This is the first that you're going to encounter some of these. Your child takes a test and they'll mail you a printout of your child's test results. And let's say they say your child got a score of 2, a standardized score of 2. What does that mean? What was their raw score? How many did they get right? So all you need to do is run this formula. We first estimate if the z-score is 2, the mean is 50, the standard deviation is 10. Here is that chart. So let's put the z-score of 2. And our estimate would say that they're going to get a score of 70. So let's run that and find out. We are looking this time to solve for x. So x equals z times standard deviation. X equals 2 times 10. What am I doing wrong here? Plus m, that's what I forgot to put. X equals z times standard deviation plus m. And sorry, I forgot to write that down. And so we add the mean to that. So 2 times 10 equals 20 plus 50 equals 70. And so we have to go z times standard deviation plus m. And I didn't have that written down up there. And I'll write this here too. And so if we were going to figure out the raw score in this example for someone who had a z-score of -1, we would do it the same way. We would go x equals the z-score is -1 times the standard deviation of 1 plus m equals -1 plus m plus 9 equals 8. And so once again, we've done that nice calculation. And we can do the same in reverse for estimating. We always want to estimate first. So in our third example, with a mean of 85 and the standard deviation of 5, you're asked to solve what would, if the z-score is 1.5, what would the raw score be? And so the 1.5 would fall right between the 1 and the 2, right about here. And so what do we estimate would the raw score be? Something in the middle of 75 and 80. 77.5 would be my estimate. And we could run the calculation to figure out if we're right. Estimate and the calculation would just be the raw score equals z-score 1.5 times standard deviation 15 plus 85 equals 1.5 times 15 is 22.5 plus 85 equals, in fact, 77.5. So in this last example, the person just used the formula and they knew they had to find the raw score for a z-score of -0.5, and they did this. So the z-score that they're solving for is -0.5, and so they made a mathematical mistake, and they found that the raw score, they got this answer, x equals 26. So if you didn't estimate, they could make this calculation error and not realize that they had made the error. But if they had estimated first, they would have known that a z-score of -0.5 would not be 26, because they would have plotted this and known that a -0.5 is going to be in here and that their answer is going to be somewhere between 0 and -1. And so if they got, excuse me, their answer is going to be somewhere between 22 and 24. And so if they got an answer of 26, that's not going to be right. They know their answer's got to be in here somewhere. So that's why it's really wise to estimate, and you'll find you get better and better at estimating. Now, in our last class, we had problem 1. I don't know if you worked through it yet. I'm going to put some PowerPoint up here where I have that written out. And here we come. All right, so this question was read like this. On a measure of anxiety, the mean is 79 and the standard deviation is 12. What are the z-scores for each of the following raw scores? So what you would do to solve this problem, and if you want to do this with me and turn it in, then you'll have this one done. And then I wanted to look at this next one together, but let's solve this one so that everyone can get it absolutely correct. So we're looking at a mean of 79, standard deviation of 12. Let's set that up first. So here on our whiteboard, we've got the space to solve this problem. And let's get this nice and big on the screen. So I'm going to just call on someone. This is practice problem 1, and you can write it down if you want to. Kiana, what would you do first if you were going to approach this the way we've been approaching these?
I would put down the z-scores first,
I
like
think
the
that would-
0, 1, 2, -1, -2.
Very good. And these are the z-scores. So now we have a nice starting point, -1 and -2. And Sheridan, what should we do next?
Add the 79
Good. Where should I put the 79?
under the 0.
Okay, 79. And what else, Sheridan, continuing with you, what else should we do here? The standard deviation, let's write our information down here. Mean was 79, standard deviation is 12. So what should we do next? And Ashley, Sheridan, go ahead, Sheridan. Yeah.
Is it subtract the 12 from the 79
Sure.
and
And-
then plus the 79 or plus the
Yeah.
12?
Yeah, excellent. We're going to add these 12, that is what the standard deviation is, to the 79. So what should we put under the -1? We have to subtract the 12.
67.
And we'll get 67. And what should we put under the 1? We're gonna
55. Oh, I
and
mean,
we'll put that, that's okay. I see what you're saying. You did the -2. What Sheridan did is subtracted another 12 and got 55. What should we do under the 1?
91.
91. And under the 2, we're going to do what, Asia? Add,
You're going to add 12 again to 91. So you're going to get 103.
we're going to get 103. Very good. So this sets you up really well for this problem. So if you've written this down, you're in good shape. And they asked us to solve these ones. They said A was 91, B, they put 68, and C, they put 103. So the first couple of these are pretty easy. What is the z-score if x equals 91, z equals, and we just follow this line, and what would the answer to that be?
1.
and that would be 1.
Dr. Russ, I'm not sure if you're aware, but Shanielle is participating. She's sending messages in the chat.
Thank
to
you. I wasn't aware, and I really appreciate you telling me.
Okay.
Danielle, I'm glad you're jumping in there. Sometimes on these screens, I feel like, maybe you feel the same, like there are so many different inputs. It's easy to miss things like that. So thank you. And anyone who sees that, you can read those up. I'll let Shanielle know. She probably knows. All right. All right, let's continue on and let's do C because that's a nice easy one. X equals 103. Z equals, and what's that going to be?
2.
And that's going to be 2. Now the 68, I think they meant to say 67, but they didn't. So let's go ahead and what should we do to get the exact Z score for a raw score of 68? How could we solve this based on what we were just doing in class? I told you it's okay if you just did 67, but let's just work through this a different way to get the exact score for 68. What should we do?
We're gonna use the formula you gave us.
We have to use the formula, yeah. So let's try that out. Our formula, Z equals, what comes? X minus what?
The mean.
Mean, and divide by the standard deviation. And we know, by the way, that the word for X minus N is deviation. That is the deviation. We're using it in this formula. So we could also say deviation minus divided by standard deviation. So in this case, we would need to go, oops. There we go. I'm not sure what happened there. All right, in this case, we would need to go 68 minus 67 divided by the standard deviation of 12, which equals 1 divided by 12. And so let's see, what would we estimate that this is going to be? A 68, just so we have that before we actually calculate. The score would fall right about here. And so we know it's going to be somewhere between what two Z scores? Somewhere between 0 and Ashley, do you know? The score is going to be somewhere between 0 and what other Z score? And -1, right? Because 68 is falling right about here. It's got to be a little bit higher than 67. It's falling right about here. So we know that the Z score has to be higher than -1, but lower than 0, and probably pretty close to -1. Does anyone want to give a rough estimate of what the Z score might be? And let's actually call on someone to do that. Jam, what do you think? What might that Z score be? Anyone give an estimate? Am I making a big mistake here and I'm not seeing it? You should tell me if I am. Shanielle, do you know what what we might estimate a Z score to be for 68, excuse me, the score that we're given? Is it likely to be a Z score of 1.8? Anyone? Am I muted? Did I lose the meeting? Kyle, are you with us?
I am here, but I don't know the answer.
Okay, well, I'm glad you're here anyhow. Well, let's think about this a minute then. So this is maybe looking a little bit messy here. So what we're asked is we have a score of 68. We know that a 67 is going to be a z-score of -1. And we know that because here is this line. Here is this line. This is the -1 z-score, and the -1 is right on top of the 67. We were asked to put, where would the 68 be? The 68 would be just above the 67. Does that make sense, Kyle? Kyle?
Not really.
Okay. Let's draw this out a little more, because I do think this is really important, so you're not just using a formula. Basically, it's like we're having a metric ruler and an inches ruler. So let's go back to our ruler. Here's our ruler. This is an uneven ruler. And you've seen a ruler where on one side they have centimeters, and the other side they have inches. And so they have 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5, and so on. Up on this side, they have inches. And here is 1 inch. And here is 2 inches. And here is 3 inches. So the centimeters continue on this side. And the inches are up above. And you've all seen a ruler like this. Here are the ½ inches and the 1/4 inches. And this is how our ruler is marked. And so you can kind of estimate how many centimeters are equivalent to 2 inches. So you would solve it by drawing a line from 2 inches. And what is this line closest to in the centimeter line? It's closest to the 7. Kyle, does that make sense? Maybe. So we might say 2 inches is approximately equal to 7 centimeters, according to the way I've drawn it here. That's our estimate. People, does this example make any sense to you of how we compare 2 different scales to get an answer? In this case, we're comparing inches and centimeters. Does it make sense, or have I lost all of you?
It makes sense to me. I kind of understand it. I was lost for a little bit, but I get it, kind of.
Okay, well, let's draw another scale. Let's make a ruler, but instead of putting on these inches, let's draw a blue ruler this time. Here's a ruler, actually. Can you guys see that ruler? I don't know, maybe I won't use that. Let me take it off. This allows me to draw straight lines on here, so I can at least draw a straight line then. All right, so here's another ruler. This is what we're gonna use. And let's see how I get rid of my ruler. Oh, there we go. All right, so here's another ruler. But this time, instead of inches on one and centimeters on the other, we're going to have z-scores on one end and raw scores on the other end. So our z-scores are always going to be the same: 0, 1, 2, -1, -2. This is like our ruler, and we put our little half marks in here if we want. And our raw scores are going to be a little bit different. They're going to be, let me make a different color here, 79, 91, 103, 67, and 55. Now, even though we have only these numbers marked, we know here that 0 is corresponding. I didn't draw it perfectly, but you get that that's corresponding with 0. We know that -1 is corresponding with 67 and so forth. But we also know that there are numbers in between here. So if we filled in all the other numbers, we'd have 57, 58, 59, 60, 61, 62, 63, 64. I know you can't really see these. Actually, if I make it really giant, maybe you can. But we know that even though we've marked 55 and 57, there are numbers that fall in between here. So let's start with one. Where would we find, if I was going to mark where 100 was on the bottom scale, where would I put a marker for it? Should I put the 100 marker right here between 67 and 79? Is that where 100 would fall?
No.
All right. Where should I put it? Where do you think would be where would I kind of estimate that it would fall?
By 103.
It's going to be up by the 103. Yeah, so it's going to be right around here. Now, if we were going to continue and estimate what the z-score would be for a raw score of 103, we would just, we would just draw a line going up and it would be still right about here. And what might we guess? We know it's falling between the 1 and the 2. So we know that our estimate has to be somewhere between 1 and 2. It's going to be closer to the 2. We know that what comes in the middle of all of these are the tenths. So we know that this is, for example, 1.5. So we know it's going to fall somewhere between 1.5 and 2. So what might you estimate for 100? 100.
1.7.
Maybe 1.7, because who said that, Jen? Maybe? Because if we were going to make this really precise and break it down, we know that we would have, let me just erase a little bit up here and make this a little bit neater here. We know that in between this 1 and this 2, we have all those fractions. So we have 1.1, 1.2, 1.3, 1.4, and all of those numbers are what's falling in between here. So then if we imagine those numbers in place, that's how, I think it was Jam who said we might estimate it to be 1.8, because right here is where the 1.8 might fall relative to the 1 and the 2. But we're not asked to do 100. We're asked to do 68. So if I'm going to put the 68 on the number line, where should I put the 68? Kyle, are you able to answer this question? Where would I put the 68? Should I put it close? Should I put it right about here? Whoops. Would the 68 go right about here between the 79 and the 91?
Yes.
Sorry, I lost the whiteboard a sec here. Oh no. Now we have to hope that I didn't lose all this prep I did for this class. Okay, I hope that we still have what I was working on with you. Shoot, there it is, good. All right, so here we go. So where should the 68 be? So we know that what's in between here is 55, 56, 57, and so forth. We know that here we have, over here we have 79, and the next one is going to be 80 will be between there, 83 will be between there, 85 will be between there, 90 will be between there. Coming up, we know that we have 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. All those numbers fall between. Where does the 68 fall? Does it fall between the 55 and the 67? Or does it fall between the 67 and the 79? Or between,
After the 67?
yeah, after the 67. And is it going to be closer to the 67 or to the 79? So we know now that the 68 needs to come in here.
Closer to the 67.
Closer to the 67. So we'll put it right here because it's really close. Here's our 68. This is the score we're interested in. Now let's draw this line upward to our z-scale. And we know that on our z-scale, it's also going to fall in this space. And this space is between 0 and -1. It's going to fall somewhere between 0 and -1. And what numbers are between 0 and -1? Well, let's do it first going left to right. 0, here's -1, and we know that we're going to have -0.1, -0.2, -0.3, -0.4. Let me erase that and move it. -0.5, -0.6, -0.7, -0.8, -0.9, and -1. So these are all the numbers that fall between 0 and -1. They're going backwards here. So, you know, just because the ruler goes down in the negative direction. So what number is closest to -1 up here? The 0.9 is close, the 0.8 is close. Is it possible that if we had room to fill in all these numbers here, that -0.1, -0.2, 0.3, 0.4, -0.5, and all that, what number might be right about here?
-0.9.
It could be a -0.9. So a good estimate for our problem of what if x equals 68, z equals question mark, it's really important to estimate. We know we're looking at a number between 0 and -1, and it's going to be somewhere approximately -0.9. So we know that if we get like an answer that says 1.5, there's no way that's right. We have to cross it off. We know it's got to be between 0 and -1. Kyle, is that make any more sense to you?
Yeah, thanks.
All right. So now we're going to check it. We're going to use our formula. We already did that. Our formula to calculate z, as we said, is first the deviation, which is x minus m, and divided by the standard deviation. And so we know that that equals our score, 68, minus the mean, 79, divided by the standard deviation, which is 12. We fill in the blanks again, and we find that we get 68 minus 79 is -11. divided by 12. I feel like that's not what I wrote down before. I think it is. And we find out that that equals negative 0.083. Is 0.83 in the same ballpark as negative 0.9? Did I do this right? I think I did do something wrong here. Hang on a second. Oh yeah, no. I did type that in wrong when I calculated it. So if anyone else did this, you put in your calculator negative 11 divided by 12. And what you probably got, as I should have gotten, is negative 0.9. We'll estimate to 0.92. So is negative 0.92 pretty close to negative 0.9?
Shanielle got the same answer. She put negative 0.92.
Thank you, Shanielle, for being her voice. Very good. So would you say this is close? Are we right? It's not too far off, right?
Yeah.
So that's what we want to be doing on these problems. So for that one, it's okay. I told you last time, if you want to assume that they made a mistake and they meant to write 67, which I think they did. But if you go ahead and solve it, you'll find that the actual answer, if x equals 68, z equals minus 0.92. Okay. So if you wrote that down for problem number 1, you're all set and you can turn it in this way. Now, problem 2, the reason I decided to go through these with you is this one was so messy. I'm going to show it to you on the, I wrote it out, I typed it out for us. Here it is. On an intelligence test, I think this is a bad question, but here it is. So we're going to do it together. On an intelligence test, the mean number of raw items correct is 231, and the standard deviation is 41. What are the raw actual scores on the test for people with IQs of 107, 83, and 100? And then they add, note that IQ scores have a mean of 100 and a standard deviation of 15. So we kind of have, the reason this is confusing, and I wanted to go through it with you, is what we actually have are 3 scales here. So we have this test with the raw items, and then we have this way that they report IQ scores, which is always a mean of 100 and a standard deviation of 15. And then we have the z-scores. So let's go through this together. 231 and 14 are the numbers we'll write down. So in this example, problem 2, we have mean equals 231, standard deviation equals 41. What's the, and now what they actually had a statement in they recommend is to transfer all these scores into z-scores and then apply the scale for the IQ test. So we're going to have 3 scales going here. So just for the sake of our time, which always seems to run out on us, I just can't believe it. Let's go ahead and make our z. We'll always start with the z. Then we're going to write these raw scores, and then we're going to transfer that scale one more time to our IQ scores. So you can see if this makes sense to you. Let's first put our z. What is always the mean in z? 0, and the standard deviations are always marked at 1. Our raw scores in this case are 231 with a standard deviation of 41. So we need to add the 41 plus 41 equals 272. Please let me know if I'm doing any math wrong. Plus 41 equals 313. Shanielle, am I right? Minus 41 equals 190. Minus,
Shanielle said yes.
Okay, thank you. I'm glad you're there doing the math with me. No, it's really fun doing math impromptu in front of people. And so then we have, I think, 149 here. But is that right? No, 139? Let's see. Minus 40 would be, yeah, this is right. All right, then what they're telling you is that the IQ scores has its own standard, and we'll come across these a lot. IQ scores have a mean of 100 and a standard deviation of 15. So let's write this down. And this is true. Mean equals 100 and standard deviation equals 15. So plus 15 equals 115, plus 15 equals 130, minus 15 equals 85, minus 15 equals 70. So now we have three scales that we're working with: the raw, the IQ, and the Z. And the questions are asking you, what is that question? Let me put that up again. Now I've forgotten what we're being asked. We're asked, what are the raw, the actual scores on the test for people who have IQs of 107, 83, and 100? So let's write those down. We have IQ scores 107, 83, and let me look at that last one again. And 100, that's what I thought. And 100. And so they want to know the raw scores. So we're going to look in this raw column. We're going to make some marks for these scores and let's put them in. So the first one, 107, it's going to fall. So here is our IQ scale. Let me erase that in the middle so we have a clear ground to look at this. Here is our score. Right here in the middle is about where the 107 is going to be. So let's first make an estimate. What do we think would be the raw score? It's got to be somewhere between 231 and 272. And I might make an estimate of 250 or something like that, because I think that's going to be right about in the middle. I might say raw, the estimate equals 250. And if I estimated the Z-score, I would say it falls right in the middle of 0 and 1, and I'd estimate at 0.5. So what we have to
Shanielle got the same thing, 0.5.
All right, very good, Shanielle. Thanks for jumping in here. And Asia, thanks for being her voice. That's very nice of you. Okay, let's see what we have to do then. The first thing we have to do is transform our IQ scores into Z-scores. So we have to look for a Z-score for each of these. So Z, we know that we have an IQ score of 107. Let's put our information down here first of all. So the raw data, we have IQ score, which is going to be X, is 107. What color should I choose here? X equals 107. Actually, let me make it clear what X we're talking about by using color coordination. So for our IQ score, we're using purple. So IQ score equals 107. And so that's going to be the X. And we know that we have the formula is Z equals X minus M divided by SD. And we're working with this scale right now. And so we're going to have Z equals 107 minus 100 divided by 15. Z equals 7 divided by 15. And Z equals 7 divided by 15, let me calculate that out. And we get 0.47. But now I wish they hadn't put this as the practice problem, because we have to actually go one more step. We have to go and take and calculate this z-score into a raw score. So the next thing we have to do is we're looking for x. I'm going to have to move this, move that away here. Oops. There we go. The next thing we have to do is we have to use our green, because we're calculating the raw score for this data. And we know that in this case, to go from a z-score to a raw score, we have to take the formula to get that is x equals, and we go z times SD plus M. And so that's our next formula. So this is like a two-step process. So our raw score X is Z times SD plus M. So X equals 0.47 times, and now we use the standard deviation for the raw score, 41 plus the mean of 231. Wish I hadn't assigned this one because it's unnecessarily difficult for a number 2 practice problem. So we know that we're going to take 0.47 times 0.41. And we get 0.1927. That's not right. 0.27, we should get 19.27. Yeah, 19.27 plus 231. And that brings us to 250.27. So this is the idea of that problem. And if you haven't done this yet, I think I'm going to take this one off of your requirement, because I thought it was just a second example. When I read it too quickly. But I think that's unnecessarily complicated. So I hope I didn't confuse you too much, and don't feel stressed if we lost you on that problem. So I apologize for that. Try and give different problems during the semester. I want to go over problem 3 with you, and this one is a pretty decent one actually, but we have to parse it out just a little bit, and then we'll go over some characteristics of this distribution. So problem 3 we're going to take a look at, and it's right here. So it seems really complicated, but let's think it through together. 6 months after a divorce, the former wife and husband each take a test that measures divorce adjustment. The woman scores 63 and the man scores 59. Overall, the mean score for divorced women on this test is 60, with a standard deviation of 6. And the mean score for divorced men is 55, with a standard deviation of 4. Which of the two has adjusted better to the divorce in relation to other divorced people of the same gender? What a mouthful. But let's look at this together. So we have this adjustment test. And do you think, and so I will just tell you, on the adjustment test, looking at just the first sentence, higher scores correspond with better adjustment. I have to escape out of here because for some reason I'm having trouble with I'm having trouble writing on my PowerPoints right now. It's one of those joys of technologies things. Let me see if I can get to copy that because I want to be able to write on it. Here we go. I'm going to copy this out so that we can, so that I
I
can
think
put it.
that's the wrong one.
Oh, thanks.
There it is.
Thank you. Oh, it'll be nice when we get back to whiteboards in the classroom and stuff like that. There it is. It's actually not a bad problem, and it's really a helpful one for understanding these concepts. So let's see here. So I'm going to find a blank spot on this beautiful whiteboard and paste it. All right, now I can write on it. So what we're looking at is this idea that, first off, the first sentence, like this. And so we have this score, this husband and wife, they've been divorced for 6 weeks. They take this test of divorce adjustment, meaning how well have they adjusted to the divorce? And I'll tell you that in this test, higher scores mean better adjustment. No, I'm having tech problems here. Okay, mean better adjustment. My memory might be getting full or something like that, because mean better adjustment. Okay, well, I don't think I can really teach very much if I don't have these tools working for me. So I'm going to pause on that problem, and I'm going to actually say that your homework is delayed for a week because you can't learn it if I can't teach it, but I am going to teach you one more thing using PowerPoint before we go, which does still seem to be working. And this is a really important concept as well. So let me pull this over for you. This is just an image that I used, and I'll find out what's wrong with my computer. But you recognize this as the normal distribution. Well, there are some laws about this normal distribution that just generally apply to all normal distributions. Like by a normal distribution, remember, we mean if we take all the beans in a pot and we measure them, they're going to distribute normally. Some of them are going to be smaller, some of them are going to be bigger, most are going to fall within the middle. Or if we shake 2 dice again and again and again and plot our scores, some are going to be lower, some are going to be higher, but most are going to fall in the middle. It's going to be rare to get a 12 or a 2. So these are the rules. So first off, we know that this is symmetrical. And so we know that, that right in the middle is where the halfway is. And so we know that on either half of the distribution, I'm having so many tech problems today. Half of the data points are going to be on the left and half are going to be on the right. So we could say 50% of the scores are going to be above the mean and 50% are going to be below the mean. But the standard deviation gives us more helpful information. In a normal distribution, if you measured all those beans, or if you looked out your window and you see a tree that has needles on it and you measured every single needle and plotted it, well, whatever the standard deviation was, just over a third of those scores, 34%, are going to fall right here between 0 and 1 standard deviation. And 34% are going to fall here between 0 and -1 standard deviation. That's just the way it is. What that means is that 2/3 of the scores are going to fall in the center here between -1 and 1 standard deviation, or 2/3 of the scores are going to be 1 standard deviation from the mean. 14% of the scores are going to be between 1 and 2 standard deviations, or between -1 and -2 standard deviations. So if you have a z-score of 1.5, you know that you're doing really well. You're doing better than most of the people just because of where it falls on the distribution. Not on this scale, but still true. About just over 2% of the scores are going to fall between 2 and 3 standard deviations above the mean. And just over 2% are going to fall below the mean. More than 2 standard deviations. And theoretically, this continues to infinity. So like someone could be 15 standard deviations above the mean, or you could have a needle that's really, really long for some reason. And it's so long that something's kind of weird about it, but it falls way, way, way above the mean. But this is what we have going here. And this is the next concept that we're going to work with. And since I'm having tech problems today, for which I apologize, I can't go through the content that I had planned. So I think that we're going to put a hold here, and I'll need to delay your assignment for 1 week. So anyone who's just tuning in, I think this is a good thing for us. We can get everyone caught up and on the same page. So let me just remind you that, so there's no new assignment due next week, Monday. But you do have all of the assignments. If you missed anything, you need to do it by the 13th. That's the way it's set up, and that's what's going to need to be done. So it's really important that you get everything in before the 13th. And next week, I'll send you a grade update that'll have everything you've done to date. Like if I was going to give you a grade today, that's what it would be. And so that'll be a helpful thing for you to know. The second thing is, if you are just lost, I can meet with you today. I was thinking about meeting with some people today to go over Excel. And I can do that because you have some assignments due. And at the same time, I feel a little bit, I wish I could be with you in person to do it. But if you're really struggling and you fear that you can't get your assignments in because you don't understand, because you're just not clear, then I want you to schedule a meeting with me and we can go over this. And if anyone wants to meet to get started on Excel a little bit today, I can meet after class today with those of you who might want a little more help. And as long as you can show me your screen, I can help you with that. Okay. So I don't know if there are any other questions or comments. I'll put up an announcement right away that your assignments aren't due because we had these tech problems. Anything else? Otherwise, I think we'll end this meeting. And is anyone going to come around and get some Excel help after class today? Otherwise, I can
Dr.
with you on Monday, on Tuesday.
Dr.
Yes.
This is Yolanda.
Yeah.
Is it possible I could meet with you in person?
Yeah, but not this week. So because I'm out of town. So next I'll be back Monday. And so I can meet with you next week. And I'd be very happy to meet with you in person. In fact, if I would love it to meet with some of you after class next week. And even though your assignments are due, if you were seriously going to come to meet with me after class to get some extra help with that, then I can extend that deadline for you for that firm deadline, only if you're going to meet with me after class next week. Would that work for you, Yolanda, to meet like kind of in person after class next week?
Yes, that would be good.
Okay,
But
Kyle.
I'll let you know when, maybe Tuesday. After
Yeah, we
class.
have a classroom. So I'll be in the class and you could come to the class live and then we could stay after to kind of get all these concepts cleared up so that you're in a good place. Kyle,
Okay,
does that work for you?
thank you.
I think that'll I think Kyle had talked about this with me. All right, I will look forward to that. I hope that others of you might decide, if you're struggling at all, that you might decide to come and stay after class next week. And I can also meet with you on Zoom. As long as you can show me your screen, I can help you with anything that you need help with. Or you could put your camera on what you're doing or something. Otherwise, I'll put an announcement that we're delaying the assignments, get everything else in by the 13th. And if you're going to meet with me, let me know so that I can extend that deadline for you. Thanks, everyone.
Bye, Dr. Russ.
See you next week.
Yeah.